Welcome to 2ndBSc 4th semester mathematics students. This is KVR Unit-2, lecture in mathematics, Sri Venkateswara College of Arts and Science, Amalapuram, East Godavari district, affiliated to Adikavi Nana University, Rajahmundry. Today I will explain lesson number 4 of Unit-2 series in your mathematics paper, Real Analysis. We have already completed 3 lessons on this unit. The 3 lessons consisting of definition, operations, properties, convergence, divergence, oscillation, theorems, geometric series, auxiliary series, and their problems also. Today, I will explain some important theorems. That is, first one is comparison test of first kind. Comparison test of first kind. Let sigma un, sigma vn be 2 series of positive terms such that un less than or equal to kvn for all small n belongs to capital N and small n greater than or equal to m, where m small n belongs to capital N and k belongs to R plus. Let sigma un and sigma vn be 2 series of positive terms. What is meant by positive terms? Every term of the series is non-negative, greater than 0. That is un greater than 0. And vn greater than 0. And it is also given that un less than or equal to kvn. That means nth term of the first series must be less than or equal to k times nth term of the second series, where k is a positive real number. This is the hypothesis given, and this inequality is valid for n greater than or equal to m. That means it cannot valid up to m minus 1 terms. That is u1, u2, etc. um minus 1. For that, up to that terms, this inequality is not valid. Then this inequality, that is un less than or equal to kvn, valid from mth and m plus 1th etc. terms onwards. Next. Let sequence Sn and sequence Tn be the sequences of partial sums of sigma un and sigma vn respectively, where Sn is equal to u1 plus u2 plus etc. un, Tn is equal to v1 plus v2 plus etc. vn. It is observed that again Sn can be written as u1 plus u2 plus etc. um minus 1 plus um plus um plus 1 plus etc. un. Now, Sn is equal to u1 plus u2 plus etc. um minus 1. Take it, these terms are in one bracket, plus um plus plus 1 plus etc. un in the second bracket. So, the inequality that is given in equation 1 valid for n greater than or equal to m. That means it must be valid for the terms in bracket of the second bracket, that is vm plus 1 plus etc. vn. Therefore, Sn less than or equal to, what is u1 plus u2 plus etc. um minus 1? Sm minus 1. Next, k into um plus plus 1 plus etc. un is the second sum. For the first sum, u1 plus u2 plus etc. um is equal to sm minus 1 plus k times, because the remaining n minus m terms are there, k into tn minus tm, tn minus tm. So this is less than or equal to sm minus 1 minus ktm plus ktn. Once again, sn less than or equal to sm minus 1 minus ktm plus ktn. But from hypothesis, sigma vn converges. Sigma vn converges. Implies sequence tn converges. Implies sequence tn is bounded, because every convergent sequence is bounded. Therefore, there exists a real number L belongs to R plus such that Tn less than or equal to L for all n belongs to capital N. Therefore, Sn less than or equal to Sm minus 1 minus Ktm plus Kl. This implies sequence Sn is bounded. That means sequence Sn is bounded above, and sequence Sn is an increasing sequence. Therefore, sequence Sn is monotonically increasing and bounded above. So it converges. Therefore, sigma un converges. This is the first result. Now we go to prove the second result. Now we want to prove sigma un converges implies sigma vn For the second result, sigma un diverges implies sigma vn diverges. Let us assume sigma un diverges. Sigma un diverges. If sigma un converges by result 1, then sigma un converges. Sigma un converges, then sigma un converges. It is a contradiction. Therefore, sigma vn diverges. Sigma vn diverges. Hence the second result. This is the comparison test of first kind. By using this, you can note some certain two results. Sigma u and sigma v are two series of positive terms such that un greater than or equal to kvn for all n belongs to n greater than or equal to m, where m belongs to z plus, k belongs to r plus, then sigma vn diverges implies sigma un diverges. Sigma un converges, sigma vn converges. Another one. Let sigma un, sigma vn are two series of positive terms. If there exists k1 belongs to r plus, k2 belongs to r plus, m belongs to n, such that k1 vn less than or equal to un less than or equal to k2 vn for all n belongs to n greater than or equal to m, then sigma un and sigma vn are both converge or both diverge together. This is the comparison test of first kind. What is the comparison test? Sigma n, sigma vn are two series of positive terms, un less than or equal to kvn. Un less than or equal to kvn. If sigma vn converges, then sigma un converges. If sigma un diverges, then sigma vn diverges. This is the comparison test of first. Now comparison test of second type. Let sigma un and sigma vn are two series of positive terms such that un plus 1 by un less than vn plus 1 by vn for all n belongs to n greater than or equal to m. For some fixed m belongs to n, then show that first one, sigma un converges if sigma vn converges. Second, if sigma vn diverges if sigma un diverges. Once again, sigma un and sigma vn are two series of positive terms. Then hereafter in the first comparison test, un less than or equal to kvn, whereas in this test such that un plus 1 by un less than vn plus 1 by vn for all n belongs to n, m belongs to n greater than or equal to m. Then sigma un converges if sigma vn converges. Second one, if sigma vn diverges, if sigma un diverges. Now we go to proof. Sigma un comma sigma vn be two series of positive terms. Be two series of positive terms. That is un greater than 0 comma vn greater than 0 for all small n belongs to capital N. This is the positive terms series. Next, another un plus 1 by un less than vn plus 1 by vn for all n belongs to n greater than or equal to m. That's why putting n is equal to m plus 1, m plus 2, etc. n minus 1 in the above given inequality will get um plus 1 by um less than vm plus 1 by vn, um plus 2 by um plus 1 less than vm plus 2 by vm plus 1, etc. etc. un by un minus 1 less than vn by vn minus 1. Multiplying these we get um plus 1 by into um plus 2 by um plus 1, etc. etc. um minus 1 by um minus 2 into um by n minus 1 less than vm plus 1 by vm into vm plus 2 by vm plus 1 into etc. etc. vn minus 1 by vn minus 2 into vn by vn minus 1. This implies un by um less than vn by vm. This implies un less than vn by vm into un less than um by vm, by vm into vn. Let k is equal to um by vm, then un less than or equal to kvn for all n belongs to n greater than or equal to m, k belongs to r plus. By comparison test of first type, sigma vn converges if implies sigma un converges. Second one, if sigma un diverges implies sigma vn diverges. This is the comparison test of second type. Now we go to another, that is limit comparison test. Very, very important. Limit comparison test. limit comparison test. If sigma un comma sigma vn are two series of positive terms, then the two series sigma un and sigma vn are both converges or both diverges if limit un by vn is equal to L not equal to 0. Limit un by vn not is equal to L not equal, limit not equal to 0. The quotient limit of the two series, nth terms of the two series is not equal to 0. Then the two series are both converge or both diverge. Once again, if sigma un and sigma vn are two series of positive terms and limit n tends to infinity, un by vn is equal to L not equal to 0, then first one, if sigma un and sigma vn are converges, or if sigma un or sigma vn are diverges. Now we go to prove the result. That is, let sigma un and sigma vn be two series of positive terms. What is two series of positive terms? Un greater than 0, vn greater than 0 for all n belongs to n. Next. Both are positive means the quotient is also positive. Un by vn also greater than 0. So un by sequence un by vn be a sequence of positive terms. Then limit n tends to infinity, un by vn greater than or equal to 0. Say L. This implies L greater than or equal to 0. But by hypothesis, L not equal to 0. Therefore, L greater than 0. Therefore, limit n tends to infinity, un by vn is equal to L and L greater than 0. Limit exists. This implies let epsilon greater than 0 be a real number such that 0 less than epsilon less than L. Let k1 is equal to L minus epsilon, k2 is equal to L plus epsilon, implies k1 greater than 0, k2 greater than 0. Let n tends to infinity, un by vn is equal to L, implies there exists m belongs to n such that small n belongs to n greater than or equal to m, implies mod un by vn minus L less than epsilon. This implies L minus epsilon less than un by vn less than L plus epsilon. This implies k1 less than un by vn less than k2. This implies k1 vn less than un less than k2 vn. If sigma un convergent and k1 vn less than un for all n belongs to n greater than or equal to m implies sigma vn convergent. If sigma vn convergent and un greater than or equal to k2 vn for all n belongs to n greater than or equal to m implies sigma un convergent. Third one, if sigma un divergent and un less than or equal to k2 vn for all n belongs to n greater than or equal to m implies sigma vn divergent. If sigma vn divergent and k1 vn less than un for all n belongs to n greater than or equal to m implies sigma un divergent. Therefore, sigma un and sigma vn are both converges or both diverges. This is very important, and that's why I will explain దిస్ థియరమ్ ఇన్ తెలుగు. స్టేట్మెంట్ ఈజ్ సిగ్మా యుఎన్ సిగ్మా విఎన్ అనేటువంటి రెండు పాజిటివ్ టర్మ్ సిరీస్లు మరియు లిమిట్ n టెన్స్ టు ఇన్ఫినిటీ UN/Vn = L నాట్ ఈక్వల్ టు 0 అయినప్పుడు రెండు సిరీస్లు కన్వర్జెంట్ అవ్వడం కానీ రెండు సిరీస్లు డైవర్జెంట్ అవ్వడం కానీ జరుగుతుంది అని చెప్పడమే లిమిట్ కంపారిజన్ టెస్ట్ యొక్క ముఖ్యమైన ఉద్దేశం. ఇంతకుముందు చెప్పినవి కంపారిజన్ టెస్ట్ ఆఫ్ ఫస్ట్ టైపు, కంపారిజన్ టెస్ట్ ఆఫ్ సెకండ్ టైప్, వాటిని ఉపయోగించుకుని ఈ టెస్ట్ చెప్తున్నాం. ఏమిటి లిమిట్ కంపారిజన్ టెస్ట్? సిగ్మా యుఎన్ అండ్ సిగ్మా విఎన్ అనేవి రెండు పాజిటివ్ పదాలతో ఏర్పడే సిరీస్ మరియు లిమిట్ n టెన్స్ టు ఇన్ఫినిటీ UN/Vn L నాట్ ఈక్వల్ టు 0 అయినప్పుడు సిగ్మా యుఎన్ సిగ్మా విఎన్ రెండూ కన్వర్జెంట్ అవ్వడం కానీ లేదా సిగ్మా యుఎన్ సిగ్మా విఎన్ రెండూ డైవర్జెంట్ అవ్వడం కానీ జరుగుతాయి. అది ప్రూవ్ చేయాలి. దానికి ఏం చేసామంటే మనకి UN greater than 0 పాజిటివ్ టర్మ్స్ Vn greater than 0 implies UN/Vn also greater than 0. Next sequence Sn with a sequence of partial sums of sigma UN/Vn when Vn not equal to 0 because Vn greater than 0. Limit n tends to infinity UN/Vn is equal to L. Actually the L may be for positive terms greater than or equal to 0, but by hypothesis L 0 కంటే సమానం అవడానికి వీలేదు, అంటే L greater than 0 అవుతుంది. ఇప్పుడు లిమిట్ ఎగ్జిస్ట్ అవుతుంది అంటున్నాం కాబట్టి there exists m belongs to n such that n belongs to n greater than or equal to m implies UN/Vn minus L less than epsilon. అంటే L మైనస్ ఎప్సిలాన్కి L ప్లస్ ఎప్సిలాన్కి మధ్యలో UN/Vn ఉంటుంది. L మైనస్ ఎప్సిలాన్కి L ప్లస్ ఎప్సిలాన్ మధ్యలో మనకు UN/Vn ఉంటుంది. ఇప్పుడు L మైనస్ ఎప్సిలాన్ K1 ని L ప్లస్ ఎప్సిలాన్ K2 అని అనుకుంటే K1 లెస్ దాన్ UN/Vn లెస్ దాన్ K2 అయింది. అంటే ఇంప్లైస్ K1Vn లెస్ దాన్ UN లెస్ దాన్ K2Vn. ఇప్పుడు సిగ్మా UN కనుక కన్వర్జెంట్ అయితే అవి K1Vn కనుక UN కంటే తక్కువ కానీ సమానంగా అయినప్పుడు కంపారిజన్ టెస్ట్ ఆఫ్ ఫస్ట్ టైప్ ప్రకారం సిగ్మా Vn కూడా కన్వర్జెంట్ అవుతుంది. అంటే సిగ్మా Vn కన్వర్జెంట్ అయినాడు, సిగ్మా Vn కూడా కన్వర్జెంట్. ఇప్పుడు సిగ్మా Vn కన్వర్జెంట్ అయింది అనుకోండి, సెకండ్ ఈక్వాలిటీ తీసుకుంటాం. ఏమిటది? UN లెస్ దాన్ K2Vn. అప్పుడు సిగ్మా Vn కూడా కన్వర్జెంట్ అవుతుంది. సిగ్మా UN డైవర్జెంట్ అయింది అనుకోండి, అప్పుడు UN లెస్ దాన్ K2Vn కాబట్టి సిగ్మా Vn కూడా డైవర్జెంట్ అవుతుంది. నెక్స్ట్ సిగ్మా Vn డైవర్జెంట్ అవి K1Vn లెస్ దాన్ UN అయింది అనుకోండి, అప్పుడు సిగ్మా UN కూడా డైవర్జెంట్ అవుతుంది. అంటే దీని ప్రకారం సిగ్మా UN సిగ్మా Vn రెండు కన్వర్జెంట్ అవ్వడం కానీ రెండు డైవర్జెంట్ అవ్వడం కానీ జరుగుతాయి అని తెలిసింది. నెక్స్ట్ ఏంటంటే ఇప్పుడు మనం ప్రాబ్లమ్స్ చేయాలి. నౌ వి గో టు సాల్వ్ ద ప్రాబ్లమ్స్. Now we go to solve the first problem. Show that sigma 1/2n square plus 1 converges. Second problem, sigma 1/log n diverges. First problem, sigma 1/2n square plus 1 converges. First we solve the problem, that is sigma UN is equal to sigma 1/2n square plus 1. This implies UN is equal to 1/2n square plus 1 greater than 0. Next, we know that 2n square greater than n square and also 2n square plus 1 greater than n square. This implies 1 by 2n square plus 1 less than 1 by n square for all n belongs to capital N. Let sigma Vn is equal to 1 sigma 1 by n square is equal to sigma 1 by n power p, p is equal to 2, 2 greater than 1. By auxiliary series test, sigma 1 by n square converges. Sigma 1 by n square converges. Therefore, by comparison test of first kind, un less than kvn. Therefore, sigma un is equal to sigma 1 by 2n square plus 1 converges. Second problem. Sigma 1 by log n diverges. Sigma un is equal to sigma 1 by log n. Therefore, un is equal to 1 by log n. N greater than or equal to 2, n belongs to capital N. We know that n greater than log n. N greater than log n. Suppose, for example, n is equal to 10, log 10 is equal to 1. So, 10 greater than 1. For any number, n always greater than log n. 1 by n less than 1 by log n. Implies 1 by log n greater than 1 by n. Let sigma Vn is equal to sigma 1 by n is equal to sigma 1 by n power p, p is equal to 1. For p less than or equal to 1 for the auxiliary series, sigma 1 by n power p diverges. Therefore, by comparison test of first kind, sigma un is equal to sigma 1 by log n diverges. Few more problems are to be solved. Show that sigma 1 by small n power small n converges. Sigma 1 by small n power n converges. Solution. Sigma un is equal to sigma 1 by small n power n implies un is equal to 1 by n power n. 1 by small n power n for all n belongs to capital N. We know that n power n greater than 2 power n for any number. Small n power n greater than 2 power n. For all n greater than 2, n belongs to n. This implies 1 by 2 power n greater than 1 by n power n. This implies 1 by n power n less than 1 by 2 power n. For all n belongs to n greater than 2. Let sigma Vn is equal to sigma 1 by 2 power n. Sigma Vn is equal to sigma 1 by 2 power n. It is the form of sigma r power n, r is equal to 1 by 2 less than 1. By geometric series, sigma Vn converges. By comparison test, sigma un is equal to sigma 1 by n power n converges. Now we go to another problem, very, very important. 3 problems are there. The 3 problems are if sigma, another problem, sigma un is a series of positive terms and sigma vn converges, show that sigma square root un by n converges. Second one, sigma un by 1 plus un converges. Third one, sigma un square converges. First one, sigma un is a series of positive terms and sigma un converges. Then show that sigma square root un by n converges. 2. Sigma un by 1 plus un converges. Third, sigma un square converges. Solution. Sigma un is a series of positive terms, that is un greater than 0 for all small n belongs to capital N. And sigma un converges. We know that un by n square less than 2un by n square, which implies un by n square less than un square plus 2un by n square plus 1 by n square whole square for all small n belongs to capital N. This implies un by n square less than un plus 1 by n square whole square for all small n belongs to capital N. Un by n square less than un plus 1 by n square whole square for all small n belongs to capital N. This implies 0 less than or equal to square root un by n less than un plus 1 by n square for all small n belongs to capital N. Un, sigma un converges, sigma 1 by n square converges. Therefore, sigma un plus 1 by n square also converges. And square root un by n less than un plus 1 by n square. By comparison test of first kind, sigma square root un by n converges. This is the first result. Second one. We know that un greater than 0 for all n belongs to n. 1 plus un greater than or equal greater than 1. Sigma un converges implies 1 plus un also converges. 1 plus un not equal to 0. Therefore, the quotient series sigma un by 1 plus un also converges. Third one. Un greater than 0 for all n belongs to capital N. Sigma un convergent, that is limit n tends to infinity, un is equal to L, implies sigma sequence un is bounded. Then there exists k belongs to r plus un less than or equal to k. This implies un square less than kun. This implies sigma un square convergent by comparison test of first kind. Once again, un greater than 0 and un sigma un convergent implies limit n tends to infinity un is equal to L. Series convergent means the series is bounded. When it is bounded, sequence un is bounded. Therefore, sequence un is bounded. When it is bounded, there exists a positive real number k such that un less than k. Multiplying both sides by un square less than kun. It is like un less than kvn. Sigma un convergent implies sigma un square also convergent. This is the second part. Now, very important problem, that is test the convergence of sigma 1 into 3 into 5 into etc. 2n minus 1 by 2 into 4 into 6 into etc. 2n. Once again, test the convergence of sigma un is equal to sigma 1 into 3 into 5 into etc. 2n minus 1 by 2 into 4 into 6 into etc. 2n. Therefore, un is equal to 1 into 3 into 5 into etc. 2n minus 1 by 2 into 4 into 6 into etc. 2n. Therefore, un plus 1 is equal to 1 into 3 into 5 into etc. 2n minus 1 into 2 into n plus 1 minus 1 by 2 into 4 into 6 into etc. 2n into 2 into n plus 1. 2 into n plus 2, sorry, not n plus 2. 2 into n plus 2. This on simplification we get un plus 1 is equal to 1 into 3 into 5 into etc. 2n minus 1 into 2n plus 1 whole by 2 into 4 into 6 into etc. 2n into 2n plus 4. Now un plus 1 by un is equal to 2n plus 1 by 2n plus 2. Let Vn is equal to 1 by n. Vn plus 1 is equal to 1 by n plus 1. Vn plus 1 by Vn is equal to n by n plus 1. Multiplying numerator and denominator by 2 implies Vn plus 1 by Vn is equal to 2n by 2 into n plus 1 is equal to 2n by 2n plus 2. This is Vn plus 1 by Vn. We know that 2n plus 1 greater than 2n implies 2n plus 1 by 2n plus 2 greater than 2n by 2n plus 2. Therefore, un plus 1 by un greater than Vn plus 1 by Vn. Vn plus 1 by Vn for all n belongs to n. Sigma Vn is equal to sigma 1 by n is equal to sigma 1 by n power p. P is equal to 1 by auxiliary series test. Sigma Vn diverges. By comparison test of second type, un plus 1 by un greater than Vn plus 1 by Vn. If sigma Vn diverges implies sigma un diverges. Therefore, sigma un is equal to sigma 1 into 3 into 5 into etc. 2n minus 1 by 2 into 4 into 6 into etc. 2n diverges. Very, very important problem. One more problem. This is also an important problem for the examination point of view also. Test the convergence of sigma square root n by n square plus 1. Sigma root n by n square plus 1. Solution. Sigma un is equal to sigma root n by n square plus 1. Sigma root n by n square plus 1 implies un is equal to root n by n square plus 1 is equal to root n by taking n square common from the denominator, n square into 1 plus 1 by n square is equal to 1 by n power 3 by 2 into 1 plus 1 by n square. Let Vn is equal to 1 by n power 3 by 2. Sigma Vn is equal to sigma 1 by n power p. P is equal to 3 by 2 greater than 1 implies sigma Vn convergent. Sigma Vn convergent. Limit n tends to infinity un by Vn is equal to limit n tends to infinity 1 by n power 3 by 2 into 1 plus 1 by n square whole by n power 3 by 2 is equal to limit n tends to infinity 1 by 1 plus 1 by n square is equal to 1 by 1 plus 0 is equal to 1 not equal to 0. By limit comparison test, both sigma Vn and sigma un are converge or diverge together. But sigma Vn converges implies sigma un is equal to sigma root n by n square plus 1 converges. One more problem. Show that sigma n plus 1 into n plus 2 by n cube root n is convergent. Sigma un is equal to sigma n plus 1 into n plus 2 by n cube root n implies un is equal to n plus 1 into n plus 2 by n cube root n. Numerator taking n common from the two factors will get n square into 1 plus 1 by n into 1 plus 2 by n cube into n power half. This implies un is equal to 1 plus 1 by n into 1 plus 2 by n into n power 3 by 2. Let Vn is equal to 1 by n power 3 by 2. Sigma Vn is equal to sigma 1 by n power p is equal to 3 by 2 greater than 1. Therefore, sigma Vn convergent. Limit n tends to infinity, un by Vn is equal to limit n tends to infinity 1 plus 1 by n into 1 plus 2 by n is equal to 1 plus 0 into 1 plus 0 is equal to 1, not equal to 0. Therefore, by limit comparison test, sigma un is equal to sigma root n by sigma n plus 1 into n plus 2 by n cube root n converges. Hence, I have completed the fourth lesson of second unit series in your mathematics paper, real analysis. We will meet in the lesson number 5 of the same unit shortly.